Welcome to the Planet of Maths channel. In today's video, we'll talk about special product formula like this. This formula will work for us in examples when we have two identical brackets, almost identical. Only the signs will differ. In one bracket, we have a minus. In the other bracket, we have a plus. Then we can use this formula. The first thing from the bracket is a, so in our case now it is 3. And the second thing from the bracket, which is x, will be b, here and here. And according to this formula, it should come out to a squared, so here it will be 3 squared. Subtract b squared, that is x squared. And just quickly exponentiate, 3 squared is 9, minus x squared written down. Generally, you use this formula quite quickly and pleasantly, but sometimes you need to be careful about certain details. In example B, we have x plus 7 times x minus 7. So we have that this is a, and this is b. We have a squared, according to the formula, which here is x squared. Subtract b squared, and for us, b is 7. 7 squared is 49. And we have the result for example B. Now example C, we have 8 minus x times x plus 8. An example seems the same, but here we don't have the same order and it's not good. We can't use formulas right away. In the formula, it is when the order is the same. So A is here, and here at the beginning in second bracket, B is at the end in the first, and at the end in the second bracket. So here we need to do something. We need to change the order in one of the brackets, and you can change the order when there is addition. In this bracket, we will swap places between x and 8. It's allowed in addition, not allowed in subtraction. We change, and then we get the operation 8 minus x times 8 plus x. We've got the order right, so we can start squaring, which means we first need to square 8, and that will be 64. Minus this x squared, that is x squared. End of example C. In example D, we have a slightly more difficult situation because our a is the expression 6x, that is a. We won't have trouble with b, b is cool. But we need to be careful with a squared, that a squared is 6x. And all this, 6x's, needs to be squared. Minus 2 squared. I raise 6x to the second power, so I raise 6 to the power of 2, which is 36, and x squared, that's x squared. Minus 2 squared, which is minus 4. That's the result for example D. In example E, I still have these somewhat more complex expressions for a and b. This is a, and this is b. Here I have the order as needed, so according to the formula, I must first square a, which is 3x squared, minus b squared, means 9y squared. And from this we get 3 squared, which is 9, and x squared, minus 9 squared is 81, and y squared. Now example F, where we have square roots, but the pattern is still the same. 4 is a, square root of 5 is b. According to our formula, I need to square a, so it is 4 squared, minus b raised to the second power, b, that is the square root of 5. So, I square this square root of 5, I end up with 16 from this 4 squared. And here the square root and second power cancel each other out, and only 5 comes out of this. The square and the square root cancel each other out, and here you can simply subtract. 16 minus 5 is 11, and that's the end of example F. In example G, I have roots again, the square root of 3 plus the square root of 7, and the square root of 7 minus the square root of 3. The order doesn't seem right to me again, and I need to change the order, but not in this bracket because there's subtraction, only in the bracket where there's addition. So, I'm swapping the square root of 3 plus the square root of 7 for the square root of 7 plus the square root of 3. It's the same, rewriting the second parenthesis without any changes. And now I can use the formula. So I need a, which is the square root of 7 squared, minus b, which is the square root of 3 to the second power. Here again, the square root and square cancels out, leaving 7. And from this, all I'm left with is the number 3, because the square root and the square cancel each other out, subtracting 7 minus 3, which is 4, and that's the end of this example. In example H, we have 2 square roots of 6 plus 3 times 2 square roots of 6 minus 3. So our A will be 2 square roots of 6, and our B will be 3. The order is correct in the brackets, so we can use the formula. We need to write A squared, which for us here is 2 square roots of 6. Necessarily in parenthesis, squared. Minus 3 squared. Well, this is going to work like this. The square has to work on the 2. 2 squared equals 4. And the square root of 6 also has to be squared, but the root and the square cancel each other out, so it's 4 times 6. Subtract 3 squared, which is 9, and we calculate 4 times 6 is 24, subtract 9, which gives us 15. Next example. We have the square root of 10 plus x to the third power and the square root of 10 minus x to the third power. The signs are as they should be. The order is correct too. So our a is the square root of 10 and our b is x to the third power. And according to the formula, first a, that means square root of 10 raised to the second power, minus b means x to the third power squared. We're squaring the square root of 10, which gives us 10, because the square root and the square cancel each other out. And here, x to the power of 3, and also to the power of 2. So the 3 and 2 multiply. And from that comes x to the power of 6. And that's it. I won't do anything more with it. And I still have example J left. Where a equals x to the fourth power, it appears here and here, and our b, it will be this entire expression. Means x roots of 3. The order is correct, AB, AB, and the signs too, in one bracket plus in another minus. According to the formula, first, I need to square a, which means x to the fourth power, and also squared, minus b squared, that is, x square roots of 3 to the second power. Raising x to the fourth and then to the second power, from this I get x to the power of 8. This square must act on x, so it will be x squared. Times the square root of 3 raised to the second power gives me the number 3. And some minor tidying up, we'll put the number 3 before x squared, and that's the result for our example. And that's all for this video. Thank you for watching, and I invite you to tune in for the next episodes on the Planet of Mass channel.